All right, greetings, AP Calculus BC. This is 2.2, finding limits. All right, we're going to do this two ways. We're going to use tables to find limits. I'm going to give you a definition for limits, and then we're going to do it by looking at some piecewise functions as well. All right, we've got about 6 slides for you, so here we go. First thing, says complete the table and use the result to estimate the limits. Okay, then use your graphing calculator to verify. All right, so here's what we got. We have this kind of crazy looking function here. It is a rational function because it has a variable in the denominator, okay? And I know that if I input the value 1, I'm going to get something undefined, which means there should not be a point at x equals 1 when I create this graphical representation of this function, okay? However, it doesn't mean that there's not something that approaches that value of 1 on both the left side and the right side. Okay, so here's what I got. 1, as you can see, is right here. What I want to know is what happens as you get closer and closer to 1, and you can see these x values do that. 0.5 to 0.9 to 0.99 to 0.999. Yeah, that gets very close to 1 from the more negative direction. And then it goes, let me fix this if I can. From this side, you can see that it goes from the right side. It goes from the more positive direction in a negative direction towards 1. So you got 1.5, 1.1, 1.01, 1.001. It gets closer to 1 from the right side. Okay, nevertheless, these are in the more positive direction from where 1 is, even though we're decreasing. Okay, and so here's what I'm going to do. I'm going to plug each one of these into my x's and figure out what it is. Okay, now some of you may be like, wow, I don't want to take 0.5 and square it and then add 3 times 0.5 minus 4 all over 0.5 minus 1. That may take a while, okay? But you can do this. You can put this in your graphing calculator. Put it in your y1, okay? So if you go to y is equal to, just make sure you put this whole thing in parentheses. Okay, and then do division divided by, it'll look like the slash, of course, x minus 1. Okay, and once you have that in there and you store it, go to your home screen. Okay, so you just have the big blank screen. Okay, and the way that you can input these numbers in super quick is just by doing y1, okay, of, and then just plug this number in, 0.5. Okay, now how do you get y1 on your screen so that you can put parentheses around it? Not a time sign, parentheses around it, because this is an input. All you have to do is hit alpha, okay, and then trace. Okay, and then the y1 will show up on your screen and you hit enter. That's assuming if you have one of the newer 84s, okay, T84s. If you have an 83, then of course you'll do, I think it's second vars, but we'll holler at me if that's your question, okay? But alpha trace will get you an option to choose the y1, and then you just hit it. And again, put parentheses around it, and it'll give you the answer, okay? And you're gonna do that with each of these. You're gonna then do y1 of 0.9, okay? y1 of 0.99, and then y1 of 0.999, and we're gonna see what we get, okay? Take a moment and try that, and see what you get. Put each of those in your calculators and then fill them into your table accordingly, okay? I'm gonna pause this just for a second so you have a chance to do it. I'm gonna do it as well, and we'll see if our answers match, okay? So pause it and give it a try. All right, if you did all of those and you've unpaused, you're not cheating, you're not just waiting for my answers, here's what I end up getting, okay? I filled in my chart. As I get closer to 1 from my x value, the corresponding y value gets closer and closer to, it looks like it gets closer to 5, okay? And so here's what I'm gonna say. I'm gonna say the limits as x approaches 1 from the negative side, okay, from the left side basically, of x squared plus 3x minus 4 all over x minus 1 is equal to 5. Okay. And now that I have that, I'm now going to do that with the other side. I'm going to start with the most positive ends, okay, 1.5, and then work my way down to 1.1, 1.01 to 1.001, and see if I notice a relationship as I get closer to 1 from the more positive side, okay, on the right side. So I'm going to ask you to do this again. Pause this just for a second. Use your graphing calculator the same way as you did over here, but instead of plugging in 0.5 and 0.9, plug in these guys instead, okay? All right, if you won't mind, pause this and we will talk further. Okay, so if you did what I did and you plugged those numbers in accurately, and if I did it right, I'm thinking I did it right, because as I get closer to 1 from the more positive direction, I can see that they get smaller and smaller and smaller, but they get closer to this value of, it looks like 5. Okay, and so that's what I'm going to write, the limits as x approaches 1 from the right hand side of x squared plus 3x minus 4 all over x minus 1 also equals 5. Okay, now here's the deal, and this seems kind of simple and obvious, but if the limits as x approaches some value from the left of your function is equal to the limits as x approaches that same value, but from the opposite side, the more positive side of f of x, okay, then what that means is that the overall limits, okay, where I don't put a side here from the left or the right, okay, will be equal to the other two. Okay, and so basically, if these are both equal to 5, then what I can say is that the limit, which is what I ask for over here, as x approaches 1 of x squared plus 3x minus 4 all over x minus 1 is equal to 5. Okay, and so yes, this does equal 5, and the limit does exist because, from both the left side and the right side, they both got close to 5. Now, does it actually touch 5? Not really, okay? Because, again, if we plugged in 1 here, we would get undefined, okay? Now, here's what I'd like you to do. I would like you to graph this. Since it's already in your Y1, hit graph, okay? And I think what you find is that you'll get a picture that kind of looks like this. Let me see if I can draw it. I can draw it well. Here's this guy. Here's this guy. And I'm going to try to draw this well. Darn it. Oh, that's awful. Let me erase that, because I was doing so well. Where are you at? Okay. I should just. I do like my eraser feature though. Okay. 4, -4. I'll do my best to draw that line. Even though it's not a straight edge, it's not perfect. Gives us something like this. Okay. However, okay, at 1, there is no point. Okay, it gets closer and closer and closer to 5 from the left side, and it gets closer and closer to 5 on the right side. But in all honesty, there's an open circle there. It doesn't actually touch 5 in a vertical sense. In fact, if you have it graphed, okay, on your graphing calculator, just hit the number 1 and hit enter. Okay. Let's see. Don't just hit 1, hit trace and then hit 1. Okay, and you'll notice that what happens is it'll give you that x value of 1, but it does not give you a corresponding y value. It's blank. Okay, so again, hit the graph button so it shows up, and then hit trace and then hit the number 1, and you'll see that it doesn't have a y value. You're like, what the heck? And but that makes sense because if you try to input one, it'll give you an undefined. Okay. All right, now some of you are looking at that like, gosh, that is a lot of work to represent that answer. And does the AP want that? They do want that, okay? They do want a representation that shows that from the left side and from the right side, they must be equal to the same thing in order for the overall limit to be equal to some value, okay? So keep that in mind. That's a strict definition that they like. Okay. All right, here's the same thing, but for another one, okay? They want to know what is the limit as x approaches 0. And you're like, wow, what happens when you plug in 0? Well, you get square root of 4 minus 2, which gives you 0 on the denominator, which is not good. All right, so here's what I'd like you to do. Take a minute, hit pause, okay? And just plug in these numbers from the left and from the right, okay? And let's see if the left side from the left side is equal to the right side, okay? And maybe it is, and maybe it's not. But if it is, then that means that I have an answer, okay? And if it's not, then we'll talk about that. All right, so if you don't mind, take a moment and input these values into this new function. Important piece, make sure that this is in parentheses, okay? Just like on the previous page, this whole thing should have been in parentheses, just like this part. Hopefully you did that. Okay. Take a moment and give that a try. Okay, here's what I got for my inputs. You can see I did both the left side and the right side. And you can see that from the left side, the more negative direction, going to numbers closer to 0, you can see that they get closer and closer to 4. And as you go from the positive side, they get closer and closer to 0. That also looks like it gets closer to 4. So I would say that the limit from the left side is equal to the limit from the right side, okay, the more positive direction. And what that would mean is that this limits as x goes to 0. Okay, I'm not putting a little symbol up here, of x over the square root of x plus 4 minus 2 does equal some number. It looks like it does equal 4. Okay, if you were to hit graph, okay, it does look like at -4, 2, it gives you something like this, and -4, 2, and it looks like at 0, it should get close to 4. But it will never touch it. It'll actually give you something that looks kind of like this. There's an open circle there, and it continues up like that. Okay. Again, if you hit trace, okay, and then you just hit the number 0, which is what this guy is, okay, then you should find that it does locate the point right here, and it'll say x equals 0. And y is equal to, and it'll be blank if there's nothing there, okay? All right, if you ever get a left side that does not equal the right side, you would just say the limit does not exist, okay? So keep that in mind. Also, notice that for each one of my answers, I went out at least 3 place values, okay? They will say that you can round to 3 place values. If you decide not to round, that's okay, which is the kind of a weird math rule. So say my answer looked like this, 3.49862, all right? And you decided, hey, to write my answer, I'm gonna write 3.50, crud, sorry, scratch that out, yeah, it is 50. How about 499? 499, that would be correct, okay? Or if you were to actually say this, 3.498, like say you didn't round the 6 up for that 8, this would also be correct, okay? So you are allowed to write this answer one of 2 ways, as long as it has 3 place values. They won't look at the back. They'll either say, hey, truncate it to 3 place values, or they will say round it if it's necessary. Okay, and sometimes you could, and sometimes it doesn't adjust it at all. Okay, so either one of those are good. That feels weird. Like in life, we always said this was not good, but it's okay in this calculus class. All right, here we go. Piecewise functions, all right? They ask you a lot of different questions here. Some deal with limits, some do not, okay? And we wanna make sure we distinguish between the two, what they're asking for. So for example, when I say f of 0, all you're gonna do is look at where x is equal to 0 and tell me what is y. So when x, which is this axis here, is equal to 0, is there a point there? Well, yeah. And what is that point vertically? Oh, it's y equals 0. Okay? And that's what you write. Your answer is just 0. If I were to ask for 2, well, 2 looks like it's related to 2 pieces of this function. However, you'll notice that this line here at 2 has an open circle, and this parabola-looking piece here has a closed circle, which means only one of those 2 locations is significant. And the one that is significant at f of 2 is the one that's above. Okay, so if I look over to my corresponding y value, it is 4. Okay, and again, because you have a dark circle there. All right, the next one, the limit as x goes to 0 for f of x. In order for a limit to exist, remember that the limits as x approaches 0 from the left side, okay, must be equal to the limit, I'll just write it back up here, as x approaches 0 from the right side of f of x. Okay, so here's 0, that's where x equals 0. From the left side, it looks like it gets closer and closer to 0. And from the right side, the more positive side, it gets closer and closer to 0. Sorry, as it gets closer and closer to 0, it also gives you a y value of 0. So since these both turned out to be the same thing, okay, and what were they? Well, this thing was a 0, and this thing gave you a 0. And since those matched up, I can say that the overall limit is equal to 0. Okay. All right, x equals 2. That's this guy right here. And what is the limit? I did have an f of 2. We knew that was 4. But let's look at the limit for each. When I say each, what I mean is, what is the limit as x goes to 2 from the left side? And what is the limit as x goes to 2 from the right side? Are they the same or are they different? All right, so let me do this in a different color. Here's 2, and if I go from the left side, that's on this curve. It actually travels this way and gives me a value at, looks like it stops at 4 from the left. Okay. And from the right side, okay, you can see that it goes to 2. And are these equal to each other? No, they're not. The answers are not the same. So you would say the limit does not exist. Okay. If you were to look at -2, this is kind of a tricky question. -2 is way over here. And you're like, does the limit exist here? Well, it's actually easier than what you think. And what I want to know is, does the left side match the right side? Okay, well, from the left side of -2, it looks like it gets to closer and closer to a height of 1. And from the right side, it also looks like it gets closer and closer to a height of -1. So this answer from the left side was -1, the right side is -1. Since those are equal to, I would say that the overall limit, I'm just gonna recopy this problem here. This whole thing is equal to -1 since both of those are the same. Okay, there is a difference between these questions and the ones below. Okay, people ask, do I have to show all 3 parts? You do. Okay, AP is going to want to see that. If you just write a number in here, there's a great chance that you're not going to get all your points for it. Okay, so they like this definition where you show this first step, the second step, and then coming up with a conclusion based off whether those answers are equal to or not. Okay, all right. This one, I think it may be my last one. I'm going to cheat and check. It's not, sorry. Ask you to graph this piecewise function. Okay, so I'll do this first piece in purple. And remember that this is just a line. Sometimes people hate graphing piecewise functions, but you pretty much never do anything more than just a line or a parabola. And I know you can do these. X plus 6. Okay, so here is your y-intercept. It's at 6. And here is your slope. Your slope is 1/1. And you don't want the whole picture. You just want from x is less than -2. So as you were to work your way down, -2 is about right here. That's where -2 is. And your slope is 1. So as you were to travel this way, they really only want this part of it. And I'm going to draw that kind of fast. At this location, we'll have to decide whether this is an open circle or a closed circle. And there is going to be an open circle here. If you want to draw the whole line and then erase the part that's not needed so you can address this piece, then that's fine, okay? But you do not need the whole graph. All right, I'll do the next one in a kind of crazy blue here. This is x squared, and I only want it from -2 to +1. Now, I know what x squared looks like. It is a parabola. It starts at 0 here. And I don't want the whole thing. I just want to go to -2. Now, at -2, for this part of your piecewise function, if I put that in, you're going to get a y is equal to a +4. Okay, so I know it's going to come up here. It's going to fill it. And I'm going to draw this part of my parabola kind of like that. And then on the right side, at x equals 1, plug in 1. 1 squared is 1. Okay, and that is also an open circle. Excuse me, this is also an open circle as well, so these should both be open circles. Okay, open circle, that is not filled in. Okay. All right, the last one, again, people sometimes freak out over these piecewise functions, but this is just a line, okay? So I'm just gonna go up 1, draw it real lightly, and then I don't want the whole line. I'm gonna go down 2, remember this is the slope, down 2/1. So from here, go down 2/1, down 2/1. And again, I'm just drawing it kind of lightly, putting some points in. Okay, and I only want the parts where x is greater than or equal to 1. So I'm going to put a big dot right there. And, ooh, that's bad, sorry. Travel. Let's see if I can get this right. Sorry, best I can do with my pen. Okay, and this is your piecewise function. Now, keep in mind, this is a function, okay? And if you draw these right, it should make a function based off vertical line tests. So if you want to do your vertical lines and see if it matches, especially when they intersect or come close to intersecting, you can find that this is a function. So this is drawn well, okay? If you ever get these overlapping pieces, like you draw your first one and then you draw this other one and you can't pass the vertical line test, means there's a mistake somewhere. And it's probably based off something what you did for that, okay? All right, so sketch the graph and identify the values for which C has a limit that does not exist, okay? So if I look, I'm gonna ask at -2, does the limit exist? And you can see from the left side and the right side, they both go to the same location. And while they're both undefined at -2, the limit still does exist, okay? So the limit does exist at -2, okay? But as you keep traveling, that you'll see at x equals 1, the limit does not exist, okay? So sketch the graph, we did that. Identify the values for which for which the limit does exist. It exists everywhere but x equals 1. So to answer this question, you can do it a couple ways, and this is the good scholarly calculus way. You can say from -infinity to 1, union, and then from 1 to infinity. Okay, that's one way to do it. Or you could say from x is less than 1 and x is greater than 1. Okay, and that also suggests the same thing. Okay, that pretty much everywhere but 1. Okay, toughest part's probably graphing it. Okay, but after you graph it, you're golden. Okay, and again, these are designed where they're always functions. So if you got some parts that overlap vertically somewhere, something's not right. Okay. All right, here is your last one. So sketch a value, okay, that satisfies, sketch a graph of the function f that satisfies the given values, okay? Be careful with this, okay? I'm gonna ask that you pause it and give it a shot on your own because I know that I can do it, but I wanna see, can you do it? Okay, so pause it and we'll see what you get. Do it. Okay, so here's one possible option. Let's keep in mind that there are many solutions that may work, but if I look at this, okay, what that means is there is a point where x is -2 that provides a corresponding output y that is 0. So I know that my graph has to cross through -2, 0. Okay. All right, next piece is pretty much the same thing, is that when x is 2, you have to have a y that's 0. So that is here. Okay. It also says the limit at x equals -2, which is right here. Okay, it must exist, okay, and it must be equal to 0, which means from the left side, from the left, okay, it has to be equal to 0, and from the right, okay, and you have to write that, not probably in this case, but it kind of gives you an idea of what's going on. And so I'll use a different color here to draw this, green. From the left side of -2, it doesn't matter how crazy it looks, just as long as it's a function. Okay. And then also from the right, it must do that. Now, I don't want to go too far, okay, because I have to address this point somehow. I'm just going to say it goes like something like this. I don't know. All right, now the second part says the limit as x equals 2 of f of x cannot exist, okay, which means at x equals 2, okay, you cannot have a limit here, okay, but there is a value at 2 that must be equal to 0. So what I can do is I can come up next to it and actually touch it. That's okay. But for the limit to not exist means that you cannot connect it, which means, where are you at, man? Did I lose it? I did. Hold on. Okay, which means that somewhere over here, it's got to touch someplace other than 2. If it doesn't exist, that means the limit as x approaches 2 from the left side of f of x cannot equal, the limit as x approaches 2 from the right side. Okay, so that means that it can be anywhere but 2. So I'm just going to go over here and put an open circle there, so it's a function, and we are officially, let's make this look like a function, we're done. This is one example that would work, okay? Are there others that would work? Yeah, there's others. What you do on the left side versus the right side could look different, but the 3 things that must happen are: 1, you should have a filled in point here, 2, you should have a filled in point here. And 3, the limit of x equals -2, yeah, it should connect here. And the last thing is that at 2, these have to separate, okay? They cannot be next to each other. They cannot meet next to each other, okay? So there must be some gap in between it. Okay. I believe that is it, okay? So here's your homework, okay? Keep in mind that the notes are certainly helpful to help you understand the homework that you're about to do. And I think if you look here, 1 to 3, 4, 5, 6, 7, 8, 19 sort of problems, okay? So if you have any questions, holler at me. I'll be happy to help you out. And I hope you have a good rest of your day. All right, we'll talk to you soon.